Hello and welcome back to Unit 2, our second recording for our geometry section. In this lesson, we'll be talking about our similar triangles. We are here on page 34 of our lesson notes. We're sharing our screen. Here's a recap of our lesson. We left off with learning our metric system, okay, where we know that we have to memorize our structure. We are now moving forward into our geometry section, where we are looking at similar triangles and some of the notations that you'll be looking at. Keeping it very simple here, just making sure we understand what similar triangles are and how we're going to use them in our lesson, as well as what we need to know on our test. Similar triangles. Similar triangles are a picture of two triangles that have a similar shape, and they are denoted by this tilde sign, represents similar. This statement says triangle ABC. So here's triangle ABC is similar to triangle DEF. Here we note that our angles or our triangles, the order of the statement themselves, correspond to the similar triangle. So A corresponds to D, B corresponds to E, and C corresponds to the F. Similarly, they also may give you these markings where they identify the angles. The angles of your triangles here, corresponding angles have the same measure. They use these arcs here to let you know that these angles have the same measure. Here and here they share the same measure. Two arcs, they have the same measure. Three arcs, they have the same measure. Also, the ratios of the lengths of the corresponding sides are the same. They will use markings to identify that the corresponding sides, okay, the sides that correspond. So what you will see is you'll see here where they'll have like one mark representing one mark, but these are the similar sides. This will be 2 marks. And then these will be 3 marks. Just letting you know that those are the corresponding sides for each of the 2 similar triangles. Watch out for these markings. They help guide you to let you know which sides or the directions for which to read the triangle. Now here's what we're going to do. We are going to use the fact that the ratios of the lengths of the corresponding sides are the same to solve for the missing piece of the triangle. Here we are with problem 3. It says, given the similar triangles, triangle EDF and triangle BAC, find the missing sides. Here are our triangles. Triangles EDF and BAC. They want us to find side X and side Y. Now, remembering what we know about ratios, ratios are 2 fractions set equal to each other to where we can cross multiply. Now remember, in our previous lesson, we did our unit fractions where we set and we multiplied our fractions together, where we cross canceled. two different things. There are many ways to set up a ratio. I'm going to show us some different things. What's important to remember is that we should be consistent. How we start is how we should finish. So what's important is making sure that we pay attention to what's happening here. Let's focus on solving for our x first here. Remember, corresponding sides, right? Lengths of our corresponding sides are the same. So if I'm going to start off writing our letter sides first, so we can see exactly what we're doing. I'm going to relate E side ED over BA. You notice how I went from this first triangle to the second triangle. Doesn't matter, you can go from the second triangle to the first triangle as long as you're consistent with your second fraction. Now, since I went from the first triangle to the second, I'm going to go from the first triangle to the second with my second fraction. So now I'm going to get this side, DF, all over AC. So I'm set it equal to DF all over AC. We see now there's my structure, generic structure. Now I'm going to go ahead and take this and replace it with my numbers that I have so that I can solve for x. So I see that ED, that's my 2, all over 4 equals 3 over x. I have to have the x in my setup so that I can solve for it. I cannot incorporate the y in there because then I have 2 unknown variables. You have to be consistent. Now, I'm going to cross multiply so that I can solve for my x. Here I am cross multiplying. 2 times x is 2x. 3 times 4 is 12. Then I can divide by 2 to get my x by itself. And I get x equals 6. So x equals 6. Again, this is only one way to set up my ratio. You may have done it another way, okay? Now let's do y. We already found x. Feel free to replace your x with the value that you found so that you can use it if you like, okay? But we know that x is 6. So now let's solve for our y. Here's another way that we can write our ratio. Writing our fraction from just using our first triangle. Here, I want to go from 2 to y. So now here I'm going to write my generic structure so I can see what I'm doing. So again, you don't have to do this. I'm just doing this so that you can see what I'm doing. Side ED all over EF. Now, if I did that in this first triangle, here to here, I need to do that in my second triangle, here to here. So I need to go BA all over BC. Again, this is just one of the many ways we can set it up. But you see how I stayed in the same triangle for the first fraction? I need to stay in the same triangle for the second fraction. Now, here I am replacing my values. So I need 2 over y equals 4 over 6. Now I'm going to do my work. Cross multiplying, 6 times 2 is 12. 4 times y is 4y. I can divide both sides by 4. 4's cancel. I find out that y equals 4 goes into 12 3 times. Did you get the 3 too? Again, doesn't matter how you set it up, it's still going to come out to be the same value. That's the beauty of ratios, but you have to be consistent. So what's the key? Consistency is the key, right? Now, so according to our notation, here they're giving us 2 pictures. You see the markings they're giving us. Triangle ABC is similar to what triangle? Triangle what? Looking at it, here we have A, B, C is similar to triangle. That's right, L, M, N. So A, B, look at the symbols. You have one arch going to the second arch on the side with the 2 markings here. So that means that you're going to go from L, the 1, to the 2, right, with the 2 markings. So that's your goal right there, L, M, leading to the N. So L, M, N. Simply paying attention and following the patterns, okay? Let's try another one. Sometimes they will give you 2 pictures merged together into one. If this doesn't sit well with your spirit, separate them. We need to label a little extra their picture, label it. I'll show us both ways. Let's answer the first question. It says, according to our notation, let's see if we can see it. Triangle ABD is similar to triangle what? Now here is ABD. It's similar to what triangle? That's right, ECD. Right? So again, depending on how they present it to you, being able to interpret it. Now they want us to find the line segments AD and BD. So the line segment AD is right here. Now, it's kind of hidden because you got one picture on top of the other. So if you want to keep them together, here's what could help. Just extend some stuff. So you say, okay, I need to find this part right here. I'm going to make this my X right here. This length right here. Don't know what that is. Right? So if people want to get fancy and put some arrows, do that. Then BD is right here. This whole entire length. Can't hardly see it, but I'm going to draw some lines out here. And then I'm going to connect them. And I'm going to call this Y. There. Now I can see what's going on a little better. So if this works for you, do it. If it doesn't work for you and you want to separate the 2 pictures, separate them. Remember, it's not rocket science. It just has to be a depiction of what's happening. And what's most important is that you label it correctly. So if you're going to separate the picture, you'll have your first triangle, and then your second triangle. And then label. So we have A, B, D, and then we have E, C, D. AB is 12 centimeters. Then this is 8 centimeters. Then this part down here, ED, is 10 centimeters. CD is 5 centimeters. And then they want us to find this right here is going to be our X, and that this part right here, we call it Y. So now here's our two triangles, separated and labeled properly. Now we're going to find our missing parts. All right, so go ahead, set up your ratio, and find your missing parts. So pause the video here, do your work, and then we'll come back and check it out. All right, here we are. Solving for X or our AD. And here we're solving for Y. Or our BD. Solving for our X. Again, whatever setup you're using, as long as we're consistent. I'm going to set up my ratio this time using 12 over 8 here and here. And then I'm going to go from X to 10 equals X over 10. Doing my math, cross multiplying, so we get 8x equals 120. Doing my math, dividing by 8, I see that x equals, 8 goes into 120. What did we get? 15 times. So we have 15 centimeters. All right, making sure you're checking behind yourself now. Solving for our y. Again, you can replace this with your 15, so you can use it if you wanted. Okay, if not, that's fine. We have plenty of information to help us. I'm going to set up my y using a different order. I'm going to go with y over 12. Now you see which direction I went from here to here. So similarly, I'm going to go from 5 to 8. As long as I'm consistent, it's going to turn out exactly what I need it to be. Here I am cross multiplying. I get 8y. 12 times 5 is 60. And then divide by 8. Y equals 7.5. All right, did we get those values? The math is simple. Just the setup might be what the issue is, and we got to practice that. So I suggest here with one problem, you can do it several different ways to get your practice in. So do different setups of your ratios, do the math, and make sure you get the same answer every time. All right? That way you have less work. Okay? This next portion here, you have to know this stuff. That's right. Put a star by this. Okay? I know that's some mathematical stuff right there. Here's what you need to know. We need to know about these angles. Now, we already are familiar with the right angle, right? But there's some other angles that we have. We have an acute angle. An acute angle holds the degrees between 0 and 90 degrees non-inclusively. Now, don't try and overthink this. It simply means that it's an angle that falls between 0 and 90. Do not try and pick values that fall in between these numbers. When they ask you about an acute angle, you need to say it's between 0 and 90. Okay? Clear. Right angle has exactly a 90-degree angle. We know that. An obtuse angle, think of obtuse means greater than 90. So it's an angle that is between 90 and 180. So something that's bigger than 90, between that 90 and 180 interval, non-inclusively. Again, don't try and pick a value. Just know these values, 90 and 180. These are the key terms. 0 to 90, acute. 90 degrees, exactly right. Obtuse, over the top. 90 to 180, right? So when you fill this in on the test, I'm just saying it's probably going to be there. Then you'll have those right when you fill them in. All right. Then looking at your right triangle information. Now, a right triangle has only one 90-degree angle. Again, the right triangle, we know that it has two sides that come together to make a 90-degree angle. And we call these sides legs. A longer leg, a shorter leg, one leg or the other leg, but two legs. And they connect to make a longer side we call a hypotenuse. When we see a right triangle, our mind should click to go to what we call the Pythagorean theorem. You're familiar with this. Pythagorean theorem, we see that our triangle is labeled with letters. Our legs are labeled A and B, and it doesn't matter which one you label A or B. What's important for you to remember is that C is always your hypotenuse, every single time. So when you look on your formula sheet and you need to use that formula, you know that the value they give you for the hypotenuse, that's always going to be your C value. Now, what's our formula? The formula, A squared plus B squared equals C squared. We're going to use this formula to help us find the length of our right triangle. If something is right, this formula will tell us, it may ask you to verify, or we are able to, again, find the missing sides of our right triangle using the formula. Now, at this point, take and stop our lesson, because that's enough for us to go on. Go and work these similar triangles. Go and memorize these angles and their degrees. And start looking at our Pythagorean theorem, the formula, the sides, the numbering, and our formulas. In our next lesson, we'll start working it. I hope this lesson helps.